This is section 1.7. We are going to be evaluating functions. It must be fun, right? Fun is in functions. It has to be fun. So this is just another way to evaluate using order of operation, basically. So first of all, what is a function? I want to compare a function to that of an equation. An equation, we say, has an equal sign, but you'll see it something like this. Y equals 3x minus 8. We call that simply an equation. This down in red is what we would call a function. It's written in function notation. It has f of x. It doesn't mean f times x. F of x simply means this is function notation. We're going to put a value in for x. That's it. So, again, this is red, f of x. F of x. It's basically just another way to write an equation. We will use functions forever in your math career. Okay, we will use these a lot in Algebra 1 and Algebra 2. We use them in college algebra, trig, pre-calc, calculus, everything. You're going to use them forever. So get used to seeing function notation, something we will use often. So before we talk about what function notation is, I want to talk to you about a machine. Definitely not an artist here. Okay. So we're going to put our numbers into a machine. We're going to put our expressions into a machine. So if I put, say, a number in here, if I put 6 into this machine, I'm going to calculate what happens when I put 6 into my function. It's going to do some math in here, and then it's going to spit out a new number. It could be 9, for example, depending on whatever the function is. That's what functions are. You're going to put something in, it's going to do some work, and it's going to come out another number. Let me show you what I mean by this. I'm going to give you a function like this. Go ahead and write it down on your paper, please. It's read f of x equals negative 4x plus 7. So into my machine, I'm going to put this number right here. It says f of 2. So 2 is what's going to go into my machine. I'm going to put the number 2 into my machine. So when I put it into the function machine, what that means is I'm going to put 2 in for x. You see what I did? I took this function right here. What did I take? I took out x, and what did I replace x with? 2, and 2 came from right here. So I'm going to put 2 into my machine. I'm putting it into my function. It's going to do some math. It's going to come out another number. Well, when I do the math, right here, what do I get? What number is going to come out of this machine? It's negative 4. Negative 4 times 2 is? Negative 8 plus 7? It's going to shoot negative 1 out of the machine. I put 6 in and I get out negative 1. So again, we said negative 4 times 2 is negative 8. Negative 8 plus 7 is negative 1. Okay. I don't want to say x equals or anything. I'm simply f of negative 2 equals negative 1. If you want to say anything, you can say f of 2. I said negative 2. F of 2 equals negative 1. Okay. That simply means when I put 2 into that function, I'm going to get out negative 1. Let's try f of negative 1, please. So this time into my function, I'm taking out x, and what am I putting in? Negative 1. The negative 4 times negative 1 plus 7. Okay, so the first step is simply substitute. Substitute in. Second step is to use the order of operations. Order of operations would tell us to multiply first. What's negative 4 times negative 1? 4. And 4 plus 7? 11. 11. I could say f of negative 1 equals 11. try another one. F of x equals 3x minus 4. So this time into the f function, what am I going to replace x with? Thank you, 4. I'm going to take out x, and in x's place, I'm going to put a 4. So 3 plus 4 minus 4. Step 1 is just to substitute in. Step 2 is to use your order of operations. We, of course, would multiply first. 3 times 4 is 12. And 12 minus 4 is? Any questions before we move on? I want you to try f of negative 5 on your own, if you would, please. Substitute in and use order of operations. Good. Replace x with negative 5. That was a substitution property, wasn't it? Now we'll use our order of operations. First thing we'll do is multiply. So negative 15 minus 4 is negative 19. How many of you got that correct? I think I walked around, most of you had that as your answer. Good job. Negative 19. Okay, so we're going to take this a step further. You knew that couldn't be all we were doing, right? How about this one? I want you to copy down this function. Copy down f of x equals 2x minus 3. So what I'm wanting you to find is this right here. I want you to find f of negative 1 plus f of 2. So this is going to be a two-part series. We're first going to find f of negative 1, which we can do. And then we're going to find f of 2, which we also can do. And then what do you guess we're going to do with those answers? Add them together. So let's just calculate two different things. Let's first find f of negative 1. Let's substitute in, replace x with negative 1. Two times negative 1 is negative 2. And negative 2 minus 3 is negative 5. Is that my answer? Yes, we need to find f of 2, don't we? And then what are we going to do with our answers? Add them together. So let's go ahead and find f of 2 next. So I'm putting 2 into my function. That was substitution. Now we'll use order of operations. 2 times 2 is 4. 4 minus 3 is 1. And that's not my answer either. The problem read f of negative 1 plus f of 2. So we're going to take negative 5, that was f of negative 1, plus f of 2. What is negative 5 plus 1? Negative 4. Negative 4 is my answer. Did I lose anybody on that one? Real quick, just to make sure we're all okay with that. You guys okay with finding f of negative 1? We okay with finding f of 2? Why did I add the answers? There's a plus sign, isn't there? We just had to simply add the two values. We did negative 5 plus 1 was negative 4. Okay, let's look at another one. Okay, so we're going to use the same function as a second ago, the f of x equals 2x minus 3. This time we want to find 6 minus f of 5. 6 minus f of 5. So we're first going to calculate f of 5, and then what are we going to do with that answer?
Subtract it from 6.
Subtract it from 6, aren't we? Not minus 6, but take that answer from 6. So let's first find f of 5. So replace x with 5. 2 times 5 is 10. 10 minus 3 is 7. 7 my answer? Now, we need to do the calculation. We have f of 5. Now we need to do 6 minus f of 5. So 6 minus 7 is negative 1. Our answer is negative 1. It's like a secret code, isn't it? They're telling you this fancy function, and we're trying to do the math to figure it out. Okay? As long as you understand what the basics of a function are, These really aren't too bad. How about another one? How about this one? So f of x equals negative 4x plus 7. So we have a new function. Go ahead and copy that down. I guess we used it earlier. Negative 4x plus 7. I want you to find f of negative 3 plus 1. Why don't you try this one on your own, and then we'll come back together and see if we agree. So f of negative 3 is going to be negative 4 times negative 3 plus 7. So 12 plus 7 is 19. Is that my answer? No, we need to add what? And 19 plus 1 is 20. 20 is the correct answer. Good job, guys. Okay, these next ones are a little bit different. I've got 3 more examples that we're going to go through together. So copy these down because they are different. Let's look at this one first. So we're going to use the function f of x equals 3x minus 4. I want you to find f of r minus 2. Copy it down and then we'll talk about it. Alright, so in our previous examples, if we had something like f of 6, we would simply take 6 and put it in for x, wouldn't we? The only difference here is I don't have just a number, I've got an algebraic expression. We call that a binomial. I'm going to take that binomial and I'm going to put it in for x. So we're going to take r minus 2, not r, not negative 2, taking them both, and I'm putting them in for x. So f of r minus 2 equals 3. Because I'm putting in more than one term, I do want you to put parentheses. Put parentheses around that r minus 2. Now this is different. We've not substituted in an expression yet. It's the same process. We're taking what's in parentheses in our function, and we're replacing x with whatever's in that parentheses. In our case, it was r minus 2. So this is the problem that I'm evaluating. Ignore the left side. Ignore this. If I just gave you what I've got boxed in, what would you do to simplify that? Good. We would distribute. Let's start with that. 3 times r is 3 times negative 2. Okay, write down minus 4. Trace, did I lose you? Did I lose you? You okay? Did I lose you?
Yes.
I lost you?
No, I'm good.
Okay. You guys are giving me this look like, oh my gosh, where did this come from? Are you guys okay with me distributing? Okay, stop me if I ever say something that makes no sense, because sometimes I don't make sense to myself. So stop me if it doesn't make sense, and we'll go back and try again. All I do is distribute. That's all I've done. Now, what is negative 6 minus 4? Negative 10. So we have 3r minus 10. Can I take 3 minus 10 and say this is negative 7r? Good, we can't. Why? They're not like terms. That's all I can do. That's my answer. So sometimes if we have a variable still in our problem, we may not have a number answer. It's going to be an expression. And that's okay. Let's try another one similar to this. We're going to use the function f of x equals negative 3x plus 1 this time. And I want to find f of negative 2m. F of negative 2m. So like before, we're not substituting in just a number, we're substituting in an expression, correct? So we're going to take out x, and in x's place, I'm going to replace it with negative 2m. Negative 3 is negative 2m plus 1. What is negative 3 times negative 2m? 6m plus 1. Can I add 6 plus 1 and say 7m? No. That's all I can do. These are not left terms. 6m plus 1. Okay, I've got one more. This will be our last one. Definitely copy this one down because it's even different yet. So we have f of x equals x squared plus 2x I do have more than one x in my original function, no big deal, you're simply going to substitute in for both x's. So look at this mess right here. Anybody have any idea what this means that we're going to do? What if I didn't have that 5 on there? What if I just had f of a? Don't worry about the brackets. What if I just had f of a? What would we do? We'd substitute a in, wouldn't we? And that would be it. When there's a 5 next to a bracket or a parenthesis, what does that mean we're doing with that 5? What operation does that mean we're doing? Multiplication. We're going to figure out this answer, and then we're simply going to take it times 5. That's it. So first, what's that? Just take it times 5, not 5a. So let's first find, let me back up. Let's first find f of a. So let's replace x in our function with a. A to the second power plus 2a. I just took out all the x's and I put an x. That first step okay? Just my substitution step. X is out, a is in its place. And these aren't like terms, I can't combine them because we have a squared and we have a. Okay. Now the 5, when we throw that 5 into the mix, that simply means I'm going to take 5 times whatever f of a was. Well, what is f of a? A squared plus 2a. So 5 times a squared plus 2a. What would you do with 5 outside of a bracket or a parenthesis? We're going to distribute. 5 times a squared is 5a squared. 5 times 2a is 10. And that's all I could do with this problem because I don't have like terms. Okay, we're going to do a little activity next to see how good we are with this stuff. Okay, I'm going to partner you up. Tell you what, everybody find a partner. We have an even number. I'll let you guys find your partner. Just go and get with your partner. You need a pencil and a calculator, and that's all you need. That's what. Go ahead and get with a partner. Who needs a partner? Who's got a partner? Josh. You might have a partner. You go ahead and pass out what the activity is, and I'll explain how we do it in just a second. Okay, so these are called partner problems. So to work these partner problems, somebody is going to pick the first column. So Kaysen, you'll pick one column. Olivia, you'll pick the other column. Doesn't matter which one you pick. Okay. You're both going to work the problems in your respective column. Now, the answer to problem number 1 on this side is the exact same answer as the problem on this side. So problem 1 has the same answer. Problem 2s have the same answer. Problem 3s have the same answer, and so forth. I would like for you to do the first 5 problems with your partner right now. When you're finished, I will let you know your next step.